Good morning, everyone. I think it's time we get started. We don't believe in the academic quarter hour here at Notre Dame like the old German system, but we do believe in the academic 5 minutes, but that has lapsed, and so we will begin. So for those of you who don't know me, I'm Don Howard. I'm the director of Notre Dame's Reilly Center for Science, Technology, and Values, which is hosting our conference the next 2 days. And on behalf of the Reilly Center, Notre Dame, our co-sponsors, the Notre Dame Law School, the Kroc Institute for International Peace Studies, and the Notre Dame International Security Program, I'd like to welcome everyone to what I hope is not just an interesting conference, but a conference that's productive of a lot of good and possibly some helpful change. What do I mean by that? Well, maintaining our technological advantage over our adversaries is crucial to our national security. But too often, as my good friend Bob Latiff is fond of saying, when we engage in the development of new weapons technologies, the question that we ask is, can we, rather than the should we question. And sometimes our being slow to ask those questions about ethics, law, and social impacts has unfortunate consequences. Sometimes it's just cosmetics. Sometimes it's losing control of the public debate. Sometimes it takes the form of making some really bad decisions about the direction in which we should take weapons development. At the very least, postponing a debate about ethics, law, and social impacts often complicates subsequent public discussion about policy in areas like this, complicates the discussion in ways that are, in some respects, profoundly unhelpful. DARPA, a couple of years ago, recognizing this challenge, approached the National Academy of Sciences, National Research Council, with a request that it put together an expert panel to think about not just what are the ethical, legal, and social impacts questions touching upon emerging weapons technologies, but to think also about the question how the agencies, private industry, and so forth responsible for weapons development can take ownership of the ethics, can bring an engagement with ethics, law, and social impacts in-house, as it were. The result of that committee's work is in the form of this just released report to the nation, Emerging and Readily Available Technologies in National Security, a framework for addressing ethical, legal, and societal issues. And it's this report that is the basis of our conference over the next couple of days. We are pleased to have with us a number of members of that committee, also the director of the committee, Herb Lynn. We are pleased to have with us Deputy Director of DARPA, Dr. Stephen Walker, who will be speaking tomorrow afternoon. We have with us some of the people who appeared before the committee as contributing experts, people who served as reviewers on the committee report. Plus, we are bringing to this conference several very distinguished experts on the larger array of questions about tech ethics. The whole point of bringing together all of these folks being to focus on what we have taken to calling the action-oriented latter chapters of the report. The part of the report that we think begins to break new ground on the question how you build in a sustainable way, how you build an engagement with ethics, law, and social impacts into the R&D process itself. We think this is an important challenge for the nation, one that affects not just weapons development, but technology, research, and development more generally. Notre Dame is especially pleased to be able to make a contribution to this effort because part of what we think of as the distinctive mission of the University of Notre Dame is not only our own excellence in leadership in science and engineering, but are also bringing to that task an engagement with the value dimensions of human life that is not always foregrounded in science and engineering. We at Notre Dame think that it makes an important difference to the way we do science and engineering at Notre Dame. But you're going to be hearing from a lot of experts, so rather than my going on about the content of the report and the other ambitions for our conference, let me just wrap up for the moment with a few comments about logistics over the next couple of days. Starting here, there will be refreshments available outside in the hallway during every break in the conference. Please help yourselves to those. Lunch today and tomorrow is unscripted, but we have information available about campus dining opportunities, starting with the lovely restaurants right across the street in the Morris Inn, Soren's, and Rohr's. If you have any questions about any such things, please don't hesitate to ask. You can ask me, or let me also introduce, back in the back of the room, Jessica Barron, who is the Outreach and Communications Coordinator for the Reilly Center, and can help you with just about any problem or question that you might have. On an even more practical note, the restrooms, there's a men's room directly across from the entrance to the courtroom. There's a women's room just down the hallway in that direction. And with that, I think that we are ready to begin. Oh, I have two announcements about, shall we say, casualties on the program. We lost our session chair for the late afternoon session today on cyber. My law school colleague, Mary Ellen O'Connell, was slated to chair that session. She was called away late yesterday afternoon by a family medical emergency. She will be replaced in that role by Peter Campbell, who is a brand new PhD in political science from here at Notre Dame, who has worked extensively on the issue of asymmetric conflict. That's the subject of his doctoral dissertation. And he's well versed on the issues that we're addressing here today. The most unfortunate casualty is I learned very late last night that George Lucas is not going to be able to join us for his talk on Wednesday. Travel complications is the short version of the story. And I think our plan is going to be simply to leave that section of our program blank early tomorrow afternoon, which will just give us a longer period of time for lunch tomorrow afternoon. With that, let me switch hats to my role as chair of our opening session this morning. I am delighted to be able to introduce to you for opening the conference my now very good friend and collaborator at the Reilly Center, Major General Robert Latiff, who's going to be speaking on the topic, the DARPA-sponsored National Academy Study of ELSI and Emerging Technologies, an opportunity for historically important change. Bob has had a long and distinguished career, first in the Army, then in the Air Force. He spent a long time working on weapons development issues during that career, brings a long background and expertise to the topic. We're very proud of the fact that Bob is, as we say here at Notre Dame, a triple domer with 3 degrees from the University of Notre Dame. We're prouder still of the fact that a couple of years ago we welcomed Bob back to Notre Dame as now an adjunct professor in the Reilly Center for Science, Technology, and Values. And in that role, Bob comes to campus 7 or 8 times every spring semester to co-teach a wonderfully successful undergraduate course on the ethics of emerging weapons technologies. that currently enrolls some 60 undergraduates every spring term. We could easily fill twice as many seats if we had enough personnel to offer those spaces. It's been an incredible success as a course, bringing together a remarkably diverse array of students, from ROTC cadets and mids to peace studies students. Very, very interesting class. We're very proud of it, and we're grateful to Bob for the help he has provided to us. With that, let me invite Bob to come up to the podium and open our conference. Both of them turned on?
Well, thank you, Don. And let me just begin by saying how pleased and, and honored I am, and to where's Herb? And to thank Dr. Herb Lynn for actually allowing me to present this. I should say before I begin also that there are several of the committee members who participated in this study who are in the audience, and I will certainly call upon them later on to talk more in detail about the things I'm going to cover in general. I actually chose to title this An Opportunity for Historically Important Change, because I actually, even as we were going through the committee deliberations, and now think that it is a wonderful opportunity, if we handle it right, for agencies of the government, at least, who are investing in advanced research and technology, to do some very important and needed things about looking at those. So thus the title. So it's not a new problem. As you'll see, I've got a few sort of well-known examples of that. The military has long looked at advanced technologies for its advantages, but it is a different environment, and I'll talk a little bit about why so, and then I'll only mention briefly DARPA, Dr. Walker. I think you'll probably have a lot more to say about some of the, but the one thing there is very forward-thinking organization, and along with forward-thinking organizations come opportunities both for problems and successes. And then I'll spend most of the time talking about the Academy's report. It's really a description of the structure of the report and how what we were asked to do and how we went about satisfying that task, and then conclude. So it's not a new issue. I mean, you go all the way back to the crossbow and Pope Innocent banning its use. What don't say there was that he actually banned its use against Catholics. Anyway, chemical warfare. Most people think of chemical warfare and World War I and the disastrous things that took place in the trenches. I also include things like Agent Orange, which came along with some really serious, long-term consequences that needed to be considered at the time, perhaps. Biological warfare. I'm certainly not able to address much about biological warfare, but it and chemical warfare were banned by the weapons treaties. Strategic bombing. What a lot of people don't know about strategic bombing is that there were people in the Air Force at the time that was being debated who actually fought against it and lost. And of course, the ongoing debate, 70 years later, 65 years later, about nuclear weapons and whether or not we should have used them. So it's not a new problem. But it's a different world. Obviously a different world because of the changed nature of conflict, but it's also technology convergence. The forces of technology have really changed things. And then, of course, a lot of those technologies, most of the new technologies have been dual use. and thus this term democratized, which I'll explain a little bit more. So, the changed nature of conflict. While we used to think of conflict as between armies and nations, now it's failed states and even individuals and groups, terrorist groups that we have to worry about. Asymmetrical warfare, I've heard many times, even in the deliberations in this committee, about the fact that we have these ethical dilemmas that don't bother our adversaries, perhaps, and they may actually use those against us. Of course, volunteer service, it's been around for many decades, but volunteer service really changes the nature of what we think about, in that the vast majority of the American people don't have really a clue about military service and the context of military service. And as far as soldiers and sailors and airmen and Marines are concerned, there's perhaps a different way in which we need to think about the ethical behavior vis-a-vis them as individuals. And of course, talk here about the fact that technology outpaces the laws of armed conflict. I need to broaden that by actually saying technology has outpaced laws in general. So that you can broaden that to a discussion of privacy and civil liberties. We're back in the Stone Age when it comes to thinking about laws concerning privacy and civil liberties. Just now beginning to consider those. Some of you may be familiar with these documents. They come out every 5 years. The National Intelligence Council publishes global trends documents. This one happens to be, I think, from 2025. But it actually talks about the changed situation vis-a-vis demands for resources, infectious disease, et cetera. And my good friend Gus Hunt from the CIA actually went a little further and started talking about fundamentalism and radicalism and an expectation of perfection on the part of the American people for both our military and our intelligence agencies, proliferation, and of course he ends talking about astounding commercial technologies. We'll talk about some of the military technologies, but the commercial technologies have been, in this case, much important. Another good friend, Dr. George Post, who some of you I'm sure know at Arizona State, he and many others, of course, have talked about this whole idea of technology convergence with computers and nano and bio, all of these things sort of mixing and creating really unusual opportunities, which, as he rightly talked about, ended up creating ethical, legal, and social problems. For instance, things like ubiquitous sensing and surveillance, or cognitive monitoring and behavioral modulation, dual use knowledge, all of these things, computers, bio, they're not specific to the military. And so, all of those things, again, bio, the advancement of computers, nanotechnologies, all of those have been, if not started by, then certainly pushed by DARPA, and they have a long history of actually technological surprise, as well as preventing technological surprise on the part of the adversaries and technologies. And I think it goes without saying, none of that has been without controversy. One only has to think, actually, DARPA did invent the internet, notwithstanding what Al Gore said. Stealth technology, Sputnik, I think, was a product of DARPA. So, I mean, go on and on and on. And this is what I was referring to, Dr. Walker. You've probably got a much better slide than this, but if, the Defense Sciences Office, one of the offices within DARPA, this is what they talk about: mining the far side of the far side, which I thought was kind of a cool phrase, but neuroscience, biology, nanotech, solid state, mathematics, quantum mechanics, seems to be a lot of creepiness about Big Dog, but which I think just got bought by Google, if I'm not mistaken.
The company Boston Dynamics just got bought by Google.
Yeah. And so you can see on and on. Of course, DARPA has other divisions, which I'm sure we'll talk about later. But it's not without controversy. I mean, total information awareness was the big deal several years ago with, it turns out that most of the things that were talked about in the Total Information Awareness Program are probably being done today, maybe in other places. Actually not a bad idea, a little bit ahead of its time. And there's probably some debate on that topic. The terrorism futures market got shut down because we were betting on terrorism. But it probably wasn't a bad idea because we might have been able to figure out where it was coming next. And then, of course, there's all kind of cool, creepy stuff that the media loves to make headlines with. And of course, if you really look at it closely, it's a lot of stuff that DARPA is doing for the benefit of the soldiers. Things to treat, for instance, brain injuries. But again, the media likes to have a good time with it. So this was our task. I think recognizing those issues, this was our task from the previous DARPA director. And you can read through the details. I've highlighted the important parts here. But what they asked us to do was to articulate a framework by which they could review and make decisions about investments in technologies, and then sort of recommend approaches about how they would go about perhaps controlling those technologies. I probably should have said this earlier, but I'd like to add here that while this was funded by DARPA and requested by DARPA, the intent of this report was actually to speak to all of the R&D funding agencies in the federal government. And to that end, I'm really happy to be speaking with Dr. Pat Carrick here in the room from the Air Force Office of Scientific Research. And presumably the Navy and the Army should also be interested in this as well, and maybe even the CIA. This was the committee. As you can see, there are actually a number of folks on this committee who are in the room with us today. I was the token weapons research developer. Certainly, a lot of these folks were really well-known scientists in the fields into which we delved. I always, when I talk about this, and Herb has allowed me to talk about it several times, I always like to highlight the fact that as a committee, we thought it was very important, and we actually said so in the report, we thought it was very important to commend DARPA for actually doing this. Things like this, can turn out badly for an organization, and this one we hope does not. I'm sorry?
Excuse me, just a moment.
I lost the mic. Okay. He was getting all kind of crazy sounds. So this is kind of the outline of what I'll talk about, and what's important, as Don said when he was introducing this, is you can go through the report and spend a lot of time in the early phases of it, and it's really good background material, but the desire and the hope coming out of this conference is that we will take the recommendations and the findings that we concluded in this report, along with some of the discussion that we'll have over the next couple of days, and actually implement some of these things in government agencies. Nothing really earth-shattering, quite frankly, but important. So in terms of framing the issues, we asserted, as we think is true, that technology, as I've shown in a previous chart, has always been important to national security. Our dominance is certainly not in numbers. It's always been more about technology. And technology, is, again, as I've shown, has always raised LC issues. LC, ethical, legal, societal implications. And I think it goes without saying that things that raise issues in a civilian context may have different issues in a military context and vice versa. And I've already talked about outpacing the laws, and of course there is a difference here in that many of the technologies, or at least many of the applications of the technologies that we're looking at, are actually intended to cause harm. That's what militaries mostly do, is fight wars. Compressed timelines may be necessary, although we can debate that, just how important compressed timelines are in the research and development activity. Secrecy is something that needs to be considered and discussed. And then, of course, the back and forth between military and civilian. So I'm going to sort of run through here kind of quickly what some of the technologies are. In terms of this democratized technology, if they're emerging, obviously they're new and they're unfamiliar, rapid rate of change. One only has to look at the advanced electronics to see how quickly things change. And in this case, they're readily available, which means there are low barriers to entry. Biology is an example of where they may not be able to weaponize things very well, but people can do this in their garages. So it's democratized. They're highly uncertain pathways. I think it's actually true that even in more controlled technologies that we develop as the military, it's not always certain as to how we're going to evolve in the way we use those technologies. And in the broader context, globalization, high connectivity, the DARPA-created internet has certainly helped that. And a lack of government monopoly, at least in the cases of things like stealth, and maybe some advanced space technologies, nobody else can afford it, so we have a monopoly on it. And this just describes the scope. We're talking about the conduct of research sort of more broadly than what we talk about in IRBs. Then research applications both intended and unintended, to include things like unintended consequences. So it's all sort of within the scope of this report. The report breaks the discussion down into both enabling technologies and applications. So enabling technologies, obviously talking about the convergence, things like information technology and neuroscience, both have applications, or both have importance to sort of many applications. And then applications like robotics and autonomous systems, or prosthetics and human enhancement, or cyber, or non-lethal weapons, then make use of advances in technology like information technology and neuroscience. So it's just different ways of actually looking at these. So think of information technology. Sensors everywhere. The numbers of sensors and the amount of data that it is throwing onto the communications systems are staggering. Staggering. Everything's a sensor and everything is creating data. And what do you have to do to handle all that data? Well, you have to use big data techniques. This chart, by the way, this chart is about 3 years old. I think you could probably add 30% at least to some of these numbers. It is just amazing. So there's a question about Moore's Law, whether or not that'll be able, quantum computing, cloud computing, embedded computing, social computing, software, and at least from a military point of view, data mining is really important, especially in the intelligence agencies for finding terrorists, cryptanalysis, weapon systems. So what are some of the issues? There are many. Certainly this is not a complete list, but this is the one that really gets my attention. The temptations to go beyond the limits of software reliability. When you look at some of the software that we're talking about, it's extraordinarily complex, extraordinarily large, and even a 0.99999 or 0.00001 error rate may not be good enough, particularly when you're talking about autonomous lethal systems, and I'll get to that. And then, of course, this is an entire area of discussion sort of brought to the fore by the NSA Snowden revelations about privacy and data mining and civil liberties. And I think Dr. Lin could probably talk to us at length about some of these discussions. So, neuroscience, there are neuroscientists in the room. Please pardon me if I get any of this wrong, but so this is just a description of what it is. In terms of military applications, soldiers, maybe not need to sleep, or changing their mood, or reducing their fear, or fixing brain injuries, for instance. This is what I was referring to with DARPA, doing some really marvelous work in this area for the benefit of the soldiers. There are concerns that come along with that in terms of ethics. Just a random picture. These are some of the things that are being considered for implantation in the brain. I encourage anybody who may be interested to look on DARPA's website for the REMIND program. Fascinating work. And I don't know, maybe Dr. Walker could expand a little bit on it. But so, here are some of the possible issues. Obviously, in the case of military, consent for use. Does consent for use, is it the same in the civilian world as it is in the military world? Probably not. If it gets into the civilian world, equitable access. These are really marvelous things, like some of the prosthetic devices that are being built. They're really expensive. Who gets them? Impact on privacy. Bans on self-incrimination. If you can actually read somebody's mind, what does that say? And of course, promotion. If I know neuroscientifically, how a person is going to react, and could that impact their promotion potential? So, possible. Robotics and autonomy, we talked about a good bit. Obviously, an autonomous system interacts with the world and acts on its own without human intervention. And there are all kinds of things going on here with hardware costs and software. Why do we do this? Particularly in a military context, why do we do it? Well, there are important things that robots can do that humans can't. Obviously, in the case we've seen with controlled robots and defusing bombs and those kind of things. And then, of course, to reduce cost. One only has to look at public Air Force documents to see that when we deploy all these UAVs, Predator UAVs, we deploy them with lots of people. And so the idea is to make them autonomous so that we don't have to deploy so many people. So what if one goes wrong? I mean, who's responsible? Is it the operator? Probably not. The commander maybe, or the National Command Authorities, or the vendor, or the software developer? Who is it? I mean, you can't punish a robot for making a mistake. Stress on operators. I'll get to this in a little bit. Everybody's heard the stories about the stress that the operators in Nevada face. What's the impact on the adversary? How do they perceive us? Or does it matter how they perceive us? The most controversial, though, is the business of lethal autonomous systems. And then, of course, on the civil side, infringement on civil liberties. And I've just shown a few examples here of autonomous lethal systems. And you can go from the very simple, which don't seem to present difficulty, defensive, a little, forget what they call this. The Navy calls it R2-D2, but it's a defensive system on a ship. Automatically operates. Phalanx. Then of course down here we've got the, this presumably is on the DMZ, North Korea. This is a little bit more like a landmine. It's you get in the zone, it kills you, period. End of discussion. No decision making. And then of course there are these. LOCAS was an Air Force system. I don't think it was ever fielded, but it was developed by FRL. And it's an autonomous system that's supposed to just fly around the battlefield. When it finds a target, kills it. Harpy is an Israeli. I think there are both export and Israeli versions of this, but it is an autonomous system. And then of course there's the Navy has something very similar, where this thing just lurks in the water until it finds a target going by, which it identifies as a target, and it kills it. So, and there are literally hundreds of other examples. Synthetic biology, with apologies to my synthetic biologist friends, maybe it's the same or similar end goals as genetic engineering, trying to work on detection and surveillance of diseases, and then maybe non-medical applications like fuels, new raw materials. And then a cartoon version is using genes to program cells to make products. And then of course there is a whole area of synthetic biology which gets really creepy that people worry about, and that is creating artificial life. But I think the Koreans said they did, and they didn't really. Is that right? So some of these are environmental. It could escape into the environment. That's why we have, was it level 4 facilities to work on these things? The new adversary threats. This is where a lot of this work gets very classified very fast. And then of course, talking about the artificial life business, the places that Notre Dame particularly, I think, would worry very much about things like this is, what's the sanctity of life? Impact classification, it's a new field. It's not, again, with apologies to my synthetic biologist friends, it's not all that well understood in predicting the behavior of these things, particularly, as my friend Gus Hunt says, when they get into the wild, is not well known. Cyber. We think generally in cyber about computer network defense, which is not considered here, computer network exploitation, which is the stealing stuff, and computer network attack, both physical and non-physical. So there are new kinds of harm. Economic, digital, informational, reputational, all kinds of things we can do with cyber that we couldn't do before. Big issue with attribution, although I think our friends in the Defense Department and DARPA have probably maybe come close to solving that problem, but it is still a big problem. Not only attribution, but also predicting the outcome of an attack. As we all know, you just think of the Stuxnet, the way when it got out into the environment, it went everywhere. Didn't hurt everybody, but it went everywhere. Again, into the wild. And again, the attribution question, the different actors who can do this stuff, it's democratized. Nonlethal weapons, tasers, calmatives, heat rays, I've got a couple of pictures, incapacitants, tear gas, they're all non-lethal, and they all, many of them used for crowd control, vehicle disabling, hostage rescue. You may recognize this. It's a Chechen who took over a theater in Moscow, and as a result, the Spetsnaz put fentanyl into the system, and as a result, they got all the terrorists and at the same time killed a couple of hundred hostages. And so a lot of debate as to whether or not this violated the Chemical Weapons Convention. Interesting point about all this that not a lot of people know is that the Russians completely decided to violate international law, and while the terrorists were drugged, just went ahead and killed them. So, but it's a case of a non-lethal weapon that got really lethal. Directed energy, the VMADs, this is one which they've tried to deploy this several times. I don't think they've ever really deployed it for anything operational for reasons of not being able to figure out the ROE. I had the option of either being a target or firing it. I chose to fire it rather than be the target, but it really works. So what might happen? We can use these things for coercion and torture. They don't leave marks, many of them. In addition to versus instead of, kind of, get the guy down and kill him while you're at it. And there is a big debate as to whether or not, given the opportunity to use less than lethal force, we might use force more often. And that's one of the debates. So how do we address these things? Flashing, a big flash of the obvious here. Do the best you can. So really, use a lot of sources for insight, be systematic, and engage as many people as possible, and then come back and reassess. I mean, pretty simple view. But rather than be just simplistic about it, we were asking. Now, there was a big debate in the committee as to whether or not we should create a matrix. Of course, the matrix got very large, very fast, and you could never really assure yourself that it was a complete matrix. So rather than do that, we settled on having a framework. And so the framework would be to consider it by stakeholder, by cross-cutting themes, and by sources of insight. And you can see the stakeholders, there may be more actually. And then, so, for instance, consent requirement for members of the military. We have to consider that. Military users of the technology, if it's a difficult system to use or using it impacts both physical or mental processes within the user, you should consider that. Non-military users, organizations, autonomous weapons come to mind here. Autonomous robots as members of a military team. What does that do to unit cohesion? It could give you all kinds of examples where it could be a problem, but how might the public perceive it? How might other nations perceive it, or does it matter? How might U.S. restraint or lack of affect what another nation does? So you have to consider the stakeholders. And oh, by the way, you have to, I've said it, you have to consider the public. Humanity. You can think in terms of autonomous weapons. How autonomous do they get? Or you can think in terms of enhanced soldiers. How far do we go in enhancing a soldier, and does it have an impact on humanity? What is the possibility that this technology is absolutely perfect? Or how certain are you that it's absolutely perfect? What kind of harm is it? Is it psychological? Is it physical? How does an adversary react? What happens, for instance, in some of these enhancement technologies, what happens when they get into the public domain? Or if you take a soldier who then transfers back into civil society, the implications of that. Then, of course, scale. Sources of insight. Philosophical ethics. This I call on my co-teacher here, Dr. Pence, who does a lot of this teaching for us. I mean, it's very interesting to go back into the theory of ethics, Kantian ethics, and consequentialism, and virtue ethics, which is actually one of the guys who sort of invented that is right here at Notre Dame, Alistair McIntyre. International law has a lot to say. conventions, Geneva Conventions, chemical weapons conventions, social sciences, precautionary principle, risk science and communication. How do we deal with the public? So there are all kinds of ways in which you can look at this in terms of sources of insight. And so, after the analysis, well, it's sort of trite to say that it's inevitably complete, but it is true. And anticipating unanticipated consequences is a little bit oxymoronic, but that doesn't mean we shouldn't try to do that. For the reason is that if you do, it can kind of give you a heads up or a lead, a step up when something goes really haywire and you've thought about it. So it gives you an idea to have a quick response and gives you some building blocks, and so we think that this is really important. And adjusting in mid-course. So, how do we do it? Well, there's all kinds of things. Self-regulation and awareness, laws of armed conflict, treaty compliance, reviews, weapons also, a weapon, when it finally becomes a weapon, has to go through a treaty compliance review. There are codes of ethics and social responsibility. Engineers and doctors and many scientists have codes of ethics. We have LC research, theoretical research on this stuff. Oversight bodies like IRBs, advisory boards, people who are willing to sell their services as consultants, ethics consultants. But we don't think that's enough. We don't think it's deeply enough. There was a conversation at dinner last night about within the military and the government, everybody has to take ethics training every year. That's not what we're talking about here. We're not talking about, stealing pencils. And a lot of this stuff has been, rightfully, as you might expect, been developed for civilian environments. So for the military, there are some things that, and this now speaking to DARPA and OSR and the government, awareness. The scientists and engineers need to be aware. They're great scientists, but they need to be aware that there may be problems. Accountability and responsibility. There needs to be expertise available to scientists and engineers. Access. They need time, although not necessarily calendar time, they need time. This is important, a variety of perspectives. Needs to be comprehensive, and there needs to be cooperation between project and program managers. So when a distinction between project managers and program managers, project manager being the actual person down at the desk level who's doing the work, and the program manager who's funding it and managing it. This got to be a real interesting discussion in the committee about public input is important. So, take TIA, take Snowden. If one would think back to before all those things blew up in our faces, getting some kind of public input might have been useful. But all this says is that that can quickly run away with you if you're not careful. And so, not the right term, but the DoD and the agencies actually need to control that in some way. Also, a big discussion. Quickly when you start talking to people in DARPA and other places, you end up getting into classified research. And, well, we can't tell you about that. And we think that that's sort of a red herring. There are enough people who are either cleared or clearable who could actually help in this business. And we think that that we should not use classification as a reason not to do this. As a matter of fact, there's a reason that we more of a reason that we should. And there's always this concern about the urgency of operational military needs. Yes, when we are in combat, and yes, when a soldier needs something right away, It doesn't end up being really that much about research and development, although it could. So the argument about urgency is also one that we think may not be a gating issue. So, sort of getting to the summing, they pose different issues than what you get in the civilian. We should make the best effort, consider stakeholders, cross-cutting themes, and insight, reassess. And another big topic was, oh my God, we're going to impose upon the agencies another TQM. For those of you old enough to understand TQM, that's not what this is all about. We actually do believe, I think we all believe, that you can do this without overly burdening the agencies, or for that matter, importantly, slowing down the research. So findings, they're different. I think I said that. Hard to anticipate. And I'll get to this in the recommendation. Sustainable policy requires the decision makers, not a staff person, but the decision makers. Public reaction is important, and you have to address implementation. So the recommendation is that senior leadership has to be engaged with some kind of designation of accountability within the organization. And they, as I've talked about, is deploying these 5 processes: initial screening, reviewing proposals, monitoring the projects, engaging with the public, and then going back and reviewing. It's you can get into a process here. So, educate and sensitize program managers, build external expertise, and provide some assistance. This is where, and if there were going to be any demand on the resources of the organization, this might be where it would come, where you would provide a little bit of extra resources, both funding and personnel, to be able to do this at the research level. And that just summarizes what I just said. And our conclusion is that there is an opportunity here, and hopefully as we go through the next 2 days, we'll use the discussions to sort of identify any additional kind of implementations that we can bring to this. If you have any questions about this, you can ask Dr. Herb Lynn. And I'll just use this. No, Don didn't know I did this, but this describes the weapons ethics course. And the only reason I put it up here is if you read this course we teach, this is precisely what we've been talking about in this report. So I may adopt it as a textbook. Thank you. How did I do on time?
So we have about 15 minutes for questions and answers, or Q&A. Is that on?
Yes.
Yeah, okay. So we do have some microphones here. I ask you please, if you have a question for Bob, please let me bring you a microphone. Floor is open.
Ruth.
Thanks, Bob. That was comprehensive. I think this is off, but that's okay.
I can hear you.
Just repeat the question and then.
Okay, my question is, during the course of the study, you mentioned programs like TIA a couple of times. And to the best of my belief, there were a lot of these things done during the course of that program, but it still became highly controversial. So my question is, did you look at some of the controversial case studies from the past, bounce them against the recommended framework and say, where did they fall short in thinking it through? In other words, did you test the framework?
I think we actually did. Herb, can you help with this one? There was a lot of discussion. I just don't remember it all. But we did. We talked a good bit about TIA, and that's where the discussion of public input, I think, got to be most important.
Yeah.
Do we view other examples?
No, I think that TIA was the canonical case study for that.
TIA was a canonical case study for that. We didn't examine it in great detail, but there was a sense in which there's some commentary in the report that says that program management, the first defense against ethical lapses and so on, is good judgment on the part of program officers and so on. And the fact that somebody says that, my job is to not be on the front page of the Washington Post, I mean, that actually demonstrates a certain kind of sensitivity to the issue. And there's a sense in which that's not a bad first step. We didn't say that as part of the recommendation, but there is a discussion of that point in the report. And whether or not TIA actually passed the Washington Post test is an interesting question. I think a number of people would argue no.
I actually sense a different question. I get a different question from the one that was, I think what you asked was, did we test the framework?
Yeah, because, for example, they did a privacy study. They did a number of the things. They tried to think it through. And so I don't have all the programmatic details, but I know they did a number of the steps that the framework suggests. So I guess what I'm looking at is, where did what they did fall short? And what can we learn from that? And I don't want to pick on TIA exclusively. I'm just trying to think of, candidly today, I'm not sure anything passes the Washington Post test. So that may not be the best measure. But what I'm looking for is, what can we learn from past controversies to strengthen the framework?
It's actually,
So Bob,
it's
Mike
actually
would
a
like to
good.
get into the conversation here too. Let's just-
I think Notre specifically asked us not to review their existing programs in the past, and so
Okay.
we didn't do what you are suggesting specifically. We just did the kinds of things that Herb and Bob were talking about.
Okay, fair enough.
But in terms of the framework, I want to get to the nub of that question. The framework was not developed out of whole cloth. You'll actually recall that as I went through all those examples, there were several pre-identified issues with certain technologies, and I think we actually used those issues to then actually construct the framework. But that's a good question, and we probably should do that. I think Elizabeth.
This is on.
Yeah.
I think my recollection is correct in what I'm about to say, but if not, enough of us who were there will correct me. We did immediately turn to TIA. And one of the things that I was surprised to learn was that there wasn't much current understanding of that history. And I was struck by that. It reminded me of how old I must be. But it also, I think, highlighted the fact that we haven't been keeping good historical records with a lessons learned, forward-looking, if you will, contribution.
And probably particularly pertinent to DARPA and the way it's constructed and the way the program managers.
We don't keep good records.
Well, I didn't mean keep good records.
I think the historical ongoing accounting of these kinds of situations and what we learn from them could be one of the most powerful tools we could create.
Let me endorse that point with great enthusiasm. My one regret is that we should have actually probably focused more on past cases as either exemplary cases or cautionary tales. I'm not sure that total information awareness is the worst of all possible cases. We can probably think of others. But to be systematically reviewing cases that presented problems, the hard part would be identifying those cases that did not present problems because they were properly managed, since it's always very difficult to identify dogs that don't bark. But also, I do want to note that the committee moderated its guidelines to a minor degree by looking at a couple of examples where DARPA was doing things we thought were really good. One of them was in synthetic biology for the Convergence program, where the program managers systematically set up a committee to try to evaluate ethical, legal, and social issues associated with that program. And we kind of slipped it in with a little slide smile from, I don't know how you managed to do it. But we did feel that you learn from experience and you learn from examples, and we felt a little uncomfortable with the fact that we weren't looking back as systematically as I think we should have speaking to citizens.
I was just going to respond a little bit to Tia that I was just a program manager at the time. But it's, you know, we did violate the Washington Post test. It ended up on the front page of the Washington Post. And I think it was a weird case because Admiral Poindexter was the office director.
No, I get all
And
that.
they had a symbol of an all-seeing eye or whatever. So I don't think they did the best job at the PR that they could have done. Yeah, in my talk, I'll talk a little bit about some of the things we've done at DARPA since then to elevate boundaries of law enforcement.
Thank you, Steve.
There's another question.
So this isn't about Tia, so if anybody wants to follow up on that, then I don't want to interrupt that conversation.
Could you speak up?
Oh, yeah. I hate technology, I know it's a concept. Let me come on, I hate microphones. Can you hear me?
Yeah.
Okay. It's not a question about Tia, but I don't want to interrupt that conversation. Oh, okay. Thank you. I'm sure you do. So, I'm Tanisha Bazal from the Notre Dame in Political Science MP Studies, and I wanted to ask you about a comment that you made on one of your early slides that rapid technology evolution is outpacing the laws of armed conflict. And I agree with you, but I was curious to hear your and the perspective of other people in the room views on where you see this particular problem or the nexus between technology and armed conflict, where that problem is most acute, and which solutions right now you find most promising. And this is a very self-serving question because I'm writing a book on the strategic use of international humanitarian law.
Well, that's a good question, which I probably can't answer. I actually believe, and I think in the class we talk a lot about this, that the laws of armed conflict are perfectly fine the way they are. You know, things like discrimination and proportionality they're all sort of fundamental tenets of the law of armed conflict. What we haven't actually done very well is keep up with the application of those laws to the current sets of technologies. And so it's not necessarily that the laws of armed conflict need to be changed. It's that we need to probably do a better job of trying to figure out how to apply them.
So if I could just follow up, is there a particular arena where you think where there's been too much of a delay or lag in application?
None in particular. I mean, I think the autonomous systems is probably one that requires a good bit of thought. Nonlethal weapons, probably each of those. Cyber warfare, understanding, you know, discrimination and our ability to conduct cyber warfare is huge. That doesn't make discrimination any less important as a law of armed conflict. It's just, you know, what do we do about applying those laws? So I don't know. Does that help in any at all? Don't. Others, yeah.
So one aspect that certainly came up in the report, and we've written about it in other contexts as well. What Bob was talking about was laws of war as defined in while you're actually in a conflict. There are others, of course, another set of laws of war that affect, that's in the ad bellum. You know, how do you know you're in a war and what justifies going to war in some sense? And I think there are a variety of other issues that come up. For example, the nature of harm. Cyber, for example, poses the question of potentially large-scale societal harm, economic harm, for example, that doesn't implicate the traditional stuff of people dying and a building blowing up. And so, what is that context? It can cause an economic crash and panic in the streets and so on, like we do to ourselves sometimes already without such. Does that meet any kind of a reasonable threshold for, quote, use of force? Well, I mean, the use of force and armed attack and armed conflict were terms that were created in 1945. And so no one had anticipated that, you know, sort of a different domain of conflict. And so I think there are lots of questions in the balance space that don't arise, you know, that are new by some new technologies.
Carolyn has a question.
Thank you. One thing I want to compliment you on as in the basis of my question is the interlinking of these different arenas, looking at the way in which IT affects synthetic biology, affects robotics, affects neuroscience. And I think it's incredibly important because what I'm finding is that the old silo mentality is now allowing people to see that for the most part, creativity is burbling out. The advances are burbling out between these interactions between fields, which is leading me to my question about ethics. One thing I'm not certain is the divide between sort of the classified group and the public too old-fashioned to work anymore. And I'll give you an example. I hang out in hacker groups, and I'm really pretty uninterested with anybody who said, well, we can't tell you because it's classified, because I hear things what they're doing is so far advanced, and I know the people there because of what you talk about, the democratized sense of technology, that these things are rippling across in ways where, as far as my concern right now, is vast transnational organized crime networks using these technologies, which they are, and it's extremely developed. You know, repurposing first Dooku and then Flame, which no one really knew, but by the time we got to Gauss, or Gauss, or however you pronounce it, and people said pretty much we knew was a repurposed Stuxnet codeware for banking Trojans. You know, so that whole mentality of thinking about what's in and out of military and less than them, I see breaking down in interaction, but I don't know how we think about it.
Well, I'm not sure what the question was there, but there are two things come to mind. One is what we're talking about here primarily has been military government research and development for military applications. There's probably a similar set of questions, but they differ in laws anyway about law enforcement uses and applications of these things. You mentioned organized crime. Back to the question of classification, it's the age-old problem of overclassification, I think. Mostly what is classified, I think, is specific details, specific capabilities, specific requirements, you know, things that we need to do or can do in order to do a mission. You know, most of the time the technology itself, with the exception maybe of stealth or something like that, is not classified. So again, I think it's sort of incumbent upon the agencies, you know, to have a close look. And of course, it'll never happen in my lifetime that we'll declassify a lot of things, but to have a close look at what really needs to be protected, even from the LC researchers. I mean, there's probably an awful lot going on in some of these classified programs that LC researchers could look at fairly easily, as long as they didn't know precisely what the exact performance capabilities were. I'm only surmising, you know, somebody else may want to say something about it, but that didn't answer your question, but I think...
Because I think what I was getting to is how do we even begin to think about the ELSI implications once you look at the realities of the way this is emerging. And that's what you started out with, and I think that's really what I was most concerned with.
Okay.
I would like to follow an observation, which I think is very profound. I think you're saying there's a paradigm shift here in the way in which we broadly define and want to make decisions. One thing we didn't consider is not just the democratization of this technology, if we can use a controversial phraseology, but also the democratization of decision making. And so, for example, if you look at the traditional paradigm of international law, the notion is that nations come together. And then think about the Landmines Convention. That was something that arose out of individual actors pushing the international community. And I think we see that in a whole range of areas where the public decision-making. And we really don't understand how to handle that at all well, and I'm not sure we put our minds around the implications, but, and I'll say more about this afternoon, in the situation we confront with Julian Assange or with Edward Snowden, you see the public's response as really wanting to be in the decision chair, and yet they lack preparation to play that role. And that lack of preparation has a number of, I think, causes, but certainly one of them is classification.
It's obvious that there's lots to discuss, but in the interests of giving us a little bit of downtime, I'm going to call this session to an end. Join me in thanking Bob once again for a wonderful launch to our session.
Thank you.